Well, welcome, folks. This is Mr. Bergmann. Today we want to talk about the effects of plate tectonics, okay? There's no picture of Mr. Bergmann because I'm in a hotel working on podcasts. Hey, we want to learn about the effects of plate tectonics. What happens because of all this plate tectonic stuff we've been learning about? Well, there are several answers that we want to talk about. Okay, first of all, several GL words, actually two. One, two, plate tectonics and trenches. All right, when we talk about plate tectonics, all right, what we want to learn about, here we go, I've lost my pin. Hold on. Plate tectonics, of course, has to do with, it's a Greek word for builder up here. So that means it's plate building. The word tectonics means to build. And so, of course, we've learned that these plates are moving. There's divergent plate boundaries here and here. This is at the Mid-Atlantic Ridge, and we're at the Nazca Plate in South America. We have a converging plate, and Rift Valley of Africa, kind of right here, and here is another diverging plate boundary. A classic one right here is we have India crashing into the Eurasian plate, making the Himalayan mountains, et cetera, et cetera. And so that's important right there. So that's kind of the definition of plate tectonics. And we can kind of see all those plates kind of all more stylized here. We can see these plates. Each of these plates is moving in a particular direction, okay? Now, there's also something called a trench. Now, a trench is basically under the water, and it's a very deep portion of the world. Very deep portion of the world. It's very, very deep. What is it? It's deep, yes. Now, what causes it? Interestingly enough, what causes a trench is we have this subduction of the oceanic plate. Remember, the ocean is more dense. The oceanic plate is more dense than a continental, and this continental is rising over the top. And as they do this, you get a trench right there, the deep portion as it subducts. So it's very deep off the edge of a continent, the deepest portion of the, well, not the deepest, but one of the deepest portions of the Earth. And remember, what's causing this, we learned this last time, is these convection cells. This would be like the Mid-Atlantic Ridge. This is where you have the upwelling, and this is where we have volcanic activity, etc. happening, okay? Now, another way we can make trenches also is when we have an ocean and an ocean collide. Now, when you have ocean, you're both the same density, but not exactly. One's going to be a little more dense. So this one on the left here is more dense, and it subducts underneath this other ocean trench, and because it does that, it creates a plate, pardon me, and then it makes this trench. So we kind of get trenches here, ocean, and also ocean continent. Okay, not too tough to see that. Now here's the main topics I want to talk about today. It looks like 5, 6 topics, something like that. Why do we have trenches form at boundaries? Why do volcanoes form at boundaries, etc., etc.? Okay. Let's talk about trenches first. Now, well, I think I've already said this when we defined what a trench was, but I think it's important to see this, is that, again, we'll just remind, it subducts. Why? Because it subducts. What does it do? That's right, it subducts. And it subducts, pushing this underneath the ocean, or the continental plate, and the continental plate creates this long trench. You would find this on the coast of South America, the west coast of South America. Now, why do we get volcanoes at the form of boundaries? It's the same picture. You'll say, what's the difference? Well, because as this border right here, there's going to be a lot of friction, all right? Rub your hands together. Hear me rubbing my hands together? Okay, good. You rub your hands together, and it gets very, very hot. Hot. And it gets very hot, and it causes the magma to rise. And then, well, you get volcanic activity. And this is where we see all these volcanoes along this edge. You also can see this here. We have a hot spot, but that's not what causes at the boundaries, because that's not a boundary. Okay, so that's because of the boundaries. So get that down. And here's a different situation. Here we have or ocean. We've got the ocean, and the ocean collides with the ocean, and it dives down underneath here. And as it dives down underneath here, we get friction, and now we get volcanoes. Although this is called a volcanic island arc. This is Tonga. You get this volcanic island arc, and these are here, and it comes up an ocean, basically underwater volcanoes that have reached the surface. And now they make an island, and they kind of make an arc because they kind of follow along the plate boundary. That's right, the plate boundary. All right, and here's geographically where we would find this. So this is primarily, you can see right here, we have, guess what? We have the Aleutian Islands of Alaska. This is Alaska. You see there's a bunch of islands right here. And if you look careful right here, what do you see? That's right, you see a trench. There's a trench. It's a very deep portion of the world. because you see the plate is going this way. I got the Russian accent because the Russia is right here. Okay. As they collide, you have one plate subducting. So this plate right here is going under, and this plate here is on top, and then we get the island arc right there. And here, by the way, is the hotspot volcano of Hawaii. Hawaii! Go to Hawaii. All right. Where is the deepest place in the entire world? Well, it's called the Mariana Trench. Now, here's the Mariana Trench right here. Actually, it's actually right through here. And this is an ocean. So we've got one plate going one way and one the other way, and they're subducting. Since the islands are on this side, the islands are kind of right through here. All right, these are the islands. Then this is the one that's going under, and this is the one that's staying on the top. And so you have lots of volcanic activity here because volcanoes will follow that. These are volcanic islands right through here. And a lot of the island, in fact, I said we have a volcanic activity in the Philippines just recently. Now, this is 2010, but there was a volcano that erupted just in the last little bit here near the Philippines. One of the sort of the big hot news in the geology world in the last few weeks or so. Now, here is an important graph. So you should copy down the graph, and then we're going to fill it out, okay? All right. So where do we find these features? So if I have a trench, does it happen at a divergent boundary, a transform boundary, an ocean-ocean, an ocean-continent, or a continent-continent? So these are our 5 different varieties. Where do you find trenches? Now think about it. They're going to have at ocean-ocean converging boundaries. We just talked about that, right? That's the one in the Philippines and such. If we also have a ocean-continent boundary, it happens here, but it does not happen anywhere else. The answer is no here, no, and no. This is actually a yes here. Maybe we should say yes and no. That might be easier. What about a volcano? The volcanoes can occur at a divergent boundary. This is at like the mid-Atlantic ridge. So this is a yes. Transform boundary, no volcanoes. This would be like California and the San Andreas Fault. So yeah, at the ocean-ocean convergent, of course, that's what we just talked about just a minute ago. In ocean-continent boundaries, yes. And this would be a no. When the continent collides with the continent, you do not get volcanic activities. Hotspots. Now, where do the hotspots form? So these hotspots, really, they just occur at the divergent plate boundaries. So no, 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 and no. Okay, what about the mountains? What do you get to mountains? Well, a divergent plate boundary, that's yes, because that's like the mid-ocean ridge, and that's a mountain range. Transform is a no, actually. Ocean, yeah, we get those volcanic island arcs, so it's sort of like islands. So this is kind of a weird one. This makes islands that are mountains, so yeah. Ocean continent, definitely. These are the volcanoes like Mount St. Helens and the Andes Mountains. Continent, this is the Himalayan mountains, so that big time. Mid-ocean ridges, where do you find there? You find them here. And mid-ocean ridges are just at divergent plate boundaries. Shallow earthquakes. Now, we didn't talk too much about earthquakes. That's our next chapter, but let's talk. There's really 3 varieties of earthquakes. Shallow, mid-level, and deep. Where do you find the earthquakes? Well, for shallow earthquakes, you know where you find them? You find them in all places. Earthquakes are actually indicative of all of these types of plate boundaries, but mid-level earthquakes are a little bit different. And these occur just at 3, so you only get them at the converging zones. So the mid-level earthquakes, because there's this collision going on, that's where you get the kind of the deeper earthquakes, the mid-level ones actually. And then the worst types of earthquakes happen when we've got the ocean-ocean convergence and the ocean-continent convergence. So your worst earthquakes happen here and here, the deepest ones. So that kind of fills out an important table that I want you to understand. Now, I want to kind of summarize this whole plate tectonic stuff with a quick little video clip. Actually, I think it's about 3 minutes or something like that. And then we're going to learn some stuff from YouTube.